what we're going to cover in today's lesson are special rules with regard to interior and exterior angles of a triangle. So let's go through a couple of things. The first very simple rule is that the sum of the measures of the interior angles of a triangle total 180 degrees. And as we've talked about, it doesn't matter what type of transformation it goes, especially a dilation. If I make the triangle double the size, triple the size, half the size, it still will total 180, its angles will still total 180 degrees. Using the triangle down below, x degrees plus y degrees plus z degrees will equal 180 degrees. So, just going through a couple of very straightforward examples. If I have 79 degrees for one angle, 41 degrees for another, and x for the third, they must total 180 degrees. So I just solved this very straightforward equation so that I get x to be 60 degrees. And then if I go to the one here, 67 plus 28 plus angle P must total 180 degrees. 95 plus angle P is 180 degrees, which means angle P is 85 degrees. Okay. Now, if you take a look at the next problem, it says that I have three angles whose measures are in the ratio of 1 to 4 to 5. That means angle 2 is 4 times as big as angle 1. Angle 5 is 5 times as big. It's a ratio. Everything is in relation to the other. So when I'm trying to find the unknown here, I could attach an x to each of these because I want to figure out what do I need to multiply each number by to get their angle measure. I have 1, 4, and 5, which total 10x. I divide by 10. I get x is 18. However, I'm not done because that only tells me what the value of x is. What I still need to figure out is what the measure is of each angle. Well, it's a very straightforward substitution process. Angle 1 is 1x, so angle 1 is 18 degrees. Angle 2 is 4 times x, or 4 times 18, which is 72. And angle 3 is 5 times x, or 5 times 18, which is 90. When I add these three numbers together, I get 180 degrees. Now, the next rule is I have what's called an exterior angle of a triangle. Now, first thing is, what's an exterior angle? It's an angle formed by one side of the triangle and the extension of the adjacent side, which you'll see in a moment in the diagram, which is much easier to understand. Now, remote interior angles are in relation to the exterior angle. And what it means is each exterior angle of a triangle has two remote interior angles that are not adjacent to it. So what we're saying is there's three angles in a triangle. The exterior angle has two angles that are some way away from it, not anywhere next to it. That's what the remote part of it means. And what the rule is that the measure of a of an exterior angle is equal to the sum of the two remote interior angles. Okay, so let's now look at this through some diagrams, because it'll make it a lot easier. If we look at the diagram below, you'll see that angle Z is the exterior angle, and X and Y are the interior. X and Y are remote to Z because they're not anywhere near it. The angle inside the triangle that's near Z would be this angle here. So in this diagram, what we're saying is if you add X and Y, it's going to be the same measure as Z. So let's do that with some very simple numbers. Let's say angle X is 40 degrees. And let's say angle Z is 120 degrees. Well, I know the angle that doesn't have a letter here, but is next to Z, is 60 because they form a straight line. And then I know 60 and 40 is 100, which makes Y 80 to give me 180 degrees. Well, now if you take a look, the 80 and the 40, these two numbers, is equal to that number. Now, why does that work? Because X plus Y plus 60 have to equal 180. That's the triangle rules. And then Z plus 60 have to equal 180. They form a straight line. Well, the 60s cancel each other out. That means X plus Y has to be the same number as Z. And that's why that rule works. All right, so let's look at some examples. And we could attack these a couple of different ways. These two angles total 73 degrees. Well, under the rule we just talked about, that makes Y 73 degrees. And you can check, because 180 minus 73 is 107. So 107, 47, and 26 add to 180, and 107 and 73 add to 180. Okay? Next example. Now, this is a little bit trickier because I have P, which is an angle inside, and the other two angle measures are outside. But they are helpful because I know this angle has to be 50. They form a straight line. That's 70. They form a straight line. And that makes this one 60. And if you look, 110 is 50 plus 60. 130 is 70 plus 60. Now, here's where the rule is a necessity. Because I don't have any actual numerical values for my angles. So I need to figure out X. The only way I could figure out X is to set up an equation. And so what is the equation I'm going to set up? I know that the exterior angle of 3x minus 10 equals the other two angles added together. So now I'm going to solve this very straightforward equation. I put 25 and 15 together to get 40. I subtract an x to get the x's by themselves. I add 10. So I get 2x is 50, which means x is 25. Now I go back. I know this is 25. 25 plus 15 tells me that this angle is 40 degrees. Then 3 times 25 minus 10 gives me 65. Is 65 these two added together? Give me 65, which is what that angle is. Okay, and the last example. Well, you know that these two angles sum up to 134 degrees. So that means the other angle has to be 46 degrees. Well, these two angles are vertical to each other, so that makes this angle 46. Now, since these are both described with an x, that means angle P and angle Q are going to be equal to each other. So I have 134 degrees that I need to divide up. And since these are the same, I can divide them evenly so that each of these two angles are 67 degrees. So what we covered today were the rules on the interior angles of a triangle and the special rule with regard to an exterior angle of a triangle.